66 million years ago, a celestial body of between 10 and 15 kilometers in size was traveling towards the Earth on a direct collision course. The object was traveling at a speed of roughly 20 kilometers per second, or almost 45,000 miles per hour, roughly 20 times the speed of a rifle bullet. This deep space impactor would result in 75% of all species of animals and plants living on Earth being obliterated forever. This video was made possible by Audible. In 1978, geophysicists Glenn Penfield and Antonio Camargo were working for the Mexican state-owned oil company Petróleos Mexicanos, or Pemex. They were conducting an airborne geophysics survey over the Gulf of Mexico. Using a magnetometer, they measured the magnetic field of rocks on the Gulf floor, specifically off the coast near Chicxulub Pueblo. They intended to map out rock compositions in the Earth's subsurface as a means of finding oil drilling targets. Penfield and Camargo's magnetic survey led them to see something very odd in the data. More than 1.6 kilometers below the surface of the Yucatan Peninsula and for over 100 kilometers out into the Gulf of Mexico was a saucer-shaped underground structure with a magnetic field different from that of any known volcanic terrain. It also had an un-volcano-like symmetry. The geophysicists then obtained some onshore gravity data from the 1940s. Gravity surveys are a means of measuring differences in the density of rocks in the subsurface. This can give clues as to suitable locations to explore for resources such as oil. Looking at these images of the data, I can see why Penfield and Camargo thought they may have discovered a huge impact crater. Now, put together, the gravity and magnetic data indicated the existence of a huge ring, about 180 kilometers in diameter, half on land and half beneath the Gulf of Mexico. It was 10 times the size of any volcano, with an upward bulge at its center, similar to those seen on known, though much smaller, impact craters. Penfield and Camargo concluded that it could not be the result of a volcano. It was probably an impact crater. But proving that scientifically was a major problem. For one thing, the data upon which their conclusion rested were held in confidence by the oil company. Worse yet, the warehouse in Mexico where all the drilling core samples were supposed to have been stored and catalogued had burned down, apparently destroying everything. Just why those core samples were so important was the result of some relatively recent research involving the effects of known asteroid impacts upon assorted rocks. One of the most important of these effects is the production of what is known as shocked quartz. Common in the Earth's crust, quartz is present in most impact breccias normally. Quartz crystals are unmarked, but when an asteroid hits the ground, its powerful shock waves passing through the tiny quartz grains at a rate of 5 to 10 kilometers per second leave a unique, indelible mark. Microscopic parallel lines scored through the quartz, like three-dimensional cross-hatching. The presence of these features provides strong evidence of an asteroid impact. I'll explain more about these types of rocks and their textures and why these are important clues for determining the existence of an impact crater later in the video. Penfield and Camargo knew Pemex had drilled exploratory wells in the Gulf of Mexico and in the Chicxulub region. In 1951, one bored into what was described as a thick layer of andesite lava, about 1.3 kilometers depth in the subsurface. This layer could have resulted from intense heat and pressure of an Earth impact, but at the time of the borings it was dismissed as a lava dome, a feature uncharacteristic of the region's geology. When attempts at returning to the drill sites and looking for suitable rock samples proved fruitless, Penfield abandoned his search, published his findings, and returned to his Pemex work. At the same time, in 1980, geologist Walter Alvarez and his father, Nobel Prize-winning scientist Luis Walter Alvarez, put forth their hypothesis that a large extraterrestrial body had struck Earth at the time of the Cretaceous-Paleogene boundary. In 1981, unaware of Penfield's discovery, University of Arizona graduate student Alan Hildebrand published a draft Earth impact theory and sought a candidate crater. His evidence included greenish-brown clay with surplus iridium, containing shocked quartz grains and small weathered glass beads that looked to be tektites. Iridium is an extremely dense metal found in meteorites in much higher abundance than in the Earth's crust, and tektites are gravel-sized objects composed of natural glass formed from terrestrial debris ejected during meteorite or asteroid impacts. Hildebrand's evidence also included thick, jumbled deposits of coarse rock fragments thought to have been scoured from one place and deposited elsewhere by a megatsunami resulting from an Earth impact. Such deposits occur in many locations but seem concentrated in the Caribbean basin at the KPG boundary, or the Cretaceous-Paleogene boundary. So when Haitian professor Florentine Maras discovered what he thought to be evidence of an ancient volcano in Haiti, a young graduate student, Alan Hildebrand, suggested it could be a telltale feature of a nearby impact. Tests on samples retrieved from the KPG boundary revealed more tektite glass formed only in the heat of asteroid impacts and high-yield nuclear detonations. It wasn't until the spring of 1990 that Penfield got a call from Hildebrand, who had examined a 65 million-year-old rock layer in Haiti, only 480 kilometers from the Yucatan, and determined that the still hypothetical asteroid impact of that time must have occurred somewhere around the Caribbean. Now Hildebrand wanted to see if he and Penfield could complete the puzzle by finally locating rock samples from Penfield's Chicxulub structure. Working determinedly, they began their search for samples. By marvellous chance, they found a few breccia samples, part of the old original oil exploration drill cores. The samples had been distributed here and there in Mexico and the United States, thus escaping destruction in the Mexican warehouse fire. Penfield and Hildebrand were fortunate enough to get a hold of a few of these, including one breccia from the 14th core of the Pemex drill site called Yucatan 6, and that did it. Shock quartz samples from the Yucatan 6 breccia clinched the fact that Penfield's underground saucer was not a volcano, but rather an impact crater from a large celestial body. They had found the elusive smoking gun. The impact site and present-day crater is located a few kilometers from the present-day town of Chicxulub in Yucatan, Mexico, after which the impactor and its crater are named. The crater is estimated to be 180 kilometers or 93 miles in diameter. The depth extends well into the continental crust of the region of about 10 to 30 kilometers or 6 to 19 miles. It is the second largest confirmed impact structure on Earth, and the only one whose peak ring is intact and directly accessible for scientific research. A central peak is not seen. Instead, a roughly circular ring, or plateau, possibly discontinuous, surrounds the crater center, with the crater rim still farther out from the center. Interestingly, there is also a concentric ring of cenotes dotted around the onshore section of the rim of the impact crater. The cenotes were likely formed over time within weakened sections of rock along the crater rim. Cenotes are formed when carbon dioxide-rich water dissolves the calcium carbonate limestones in the area. The holes gradually become wider and deeper, eventually filling with water. The effects of the Chicxulub impact were devastating. A new study from 2020 suggested that the object slammed into the Earth, travelling from the northeast at an angle of about 60 degrees. The simulation shows the moment of impact. This video is only 15 seconds long, but required weeks of computing time to render. Shown here is another simulation of the impact. As the object hits the Earth, a huge hole is created instantly that extends deep into the crust. 500 billion tons of material was ejected more than 40 kilometers into the atmosphere. It's likely that up to 10,000 square miles or 20,000 square kilometers of ocean water was displaced, with a portion being vaporized. The rock at the impact site was liquefied instantly, with the temperature increasing to thousands of degrees. The simulations also show that the liquid rock in the central part of the impact site rebounded back up following the impact, rising up to 20 kilometers into the atmosphere. It's truly staggering to think of how much energy was needed to cause this event. Within minutes, the displaced seawater rushed quickly back into the impact site, covering the lake of molten rock that was formed from the settling of the rebounded rock. It's likely that a geothermal system existed for tens or hundreds of thousands of years underground at the site following the impact, with seawater being heated by the cooling sheet of the impact melt rock. During the early evolution of the Earth, impact bombardment was severe. The entire surface of the Earth was resurfaced by impact events. Some of the impact craters were thousands of kilometers in diameter, dwarfing the Chicxulub crater. Those impacts would have made conditions at the surface of the Earth hostile for any life. On the other hand, impact-generated subsurface hydrothermal systems would have been possible refuges for life. The Chicxulub impact event was a 100 million megaton blast that completely changed the Gulf of Mexico region. The blast generated a core of superheated plasma in excess of 10,000 degrees Celsius. Although that thermal pulse would have been relatively short-lived, a handful of minutes, it would have been lethal for nearby life. The impact event produced a shockwave and air blast that radiated across the seas, over coastlines and deep into the continental interior. Winds far in excess of 1,000 kilometers per hour were possible near the impact site, although they decreased with the distance from the site. The pressure pulse and winds would have scoured soils and shredded vegetation and any animals living in nearby ecosystems. An initial estimate of the area damaged by the air blast was a radius of 1,500 kilometers. Within minutes after the impact, ejecta debris began to rain back down to Earth. That debris landed within minutes in the Gulf of Mexico and the Caribbean region. Depending on the distance from the impact site, the debris was rocky rubble, molten rock, or mixtures of both. Life on the continental landscape and marine seafloor was buried beneath impact ejecta that was several hundred meters thick near the impact site and decreased with radial distance. Because the impact occurred at sea, huge tsunamis radiated across the Gulf of Mexico, crashing onto nearby coastlines and also radiated further across the Proto-Caribbean and Atlantic basins. Estimates of the sizes of the waves vary. Lower estimates suggest that the waves were up to 100 meters high, while some estimates suggested that the tsunamis were up to 300 meters high when they crashed onto Gulf shores and tore through coastal ecosystems. The tsunamis may have penetrated more than 100 kilometers inland before the backwash swept continental debris back into the Gulf of Mexico, where it was deposited in seafloor channels. Both the initial waves and resulting backwash deeply eroded the seafloor to depths of several hundred meters. The impact also generated a seismic pulse roughly equivalent to a magnitude 10 earthquake. That seismic activity caused huge landslides on the seafloor, ripping through any colonies of life. Evidence of these processes are found in the rock record around the Gulf of Mexico. Chicxulub-generated tsunami deposits exist, for example, along the Brazos River of Texas. This image shows terrestrial plant debris with marine deposits, suggesting that the plant debris was carried seaward by the backwash of the tsunami. On a global scale, calculations of impact debris raining from space back through the atmosphere suggests that debris shock heated the atmosphere, driving chemical reactions that generated nitric acid rain. Additional nitric acid rain may have been produced by impact-generated wildfires. The acid rain may have fallen for over a period of a few months to a few years. The global distribution of a layer of soot, along with elevated levels of iridium from the impactor itself at the KPG boundary, indicates ejecta was distributed globally, which caused widespread atmospheric heating and wildfires. The amount of soot recovered from the KPG boundary sediments implies that fires released huge amounts of greenhouse gases, carbon dioxide, carbon monoxide, and methane, that likely had a long-term effect on post-impact climate. Calculations of an atmosphere choked with dust and sulfate aerosols from the impact event and soot from the post-impact wildfires suggest surface temperatures fell and sunlight was unable to reach the Earth's surface, shutting down photosynthesis. A shutdown of photosynthesis may have been the most severe of the impact's environmental effects, killing plants and the animals that relied on the plants for food. The dust, aerosols, and soot may have caused significant decrease in surface temperatures of several degrees to a few tens of degrees as the Earth entered a post-impact winter, which may have lasted for years. Following this, the Earth went through a period of global warming caused by the greenhouse gases from wildfires and other dust, soot, and gases in the atmosphere. One question still remains today and has yet to be solved. Where did the impactor originate from? Our solar system? Or maybe even interstellar space? Well, one potential suspect was Baptistina, which was theorized to have crashed into another asteroid in the main belt between Mars and Jupiter about 160 million years ago. The collision sent shattered pieces as big as mountains flying. One of those pieces was believed to have impacted Earth, causing the dinosaurs' extinction. Since this scenario was first proposed, evidence developed that the so-called Baptistina family of asteroids was not the responsible party. With the new infrared observations from WISE, or Wide Field Infrared Survey Explorer, astronomers say Baptistina may finally be ruled out. WISE surveyed the entire celestial sky twice in infrared light from January 2010 to February 2011. The asteroid hunting portion of the mission, called NEOWISE, used the data to catalogue more than 157,000 asteroids in the main belt and discovered more than 33,000 new ones. Visible light reflects off an asteroid. Without knowing how reflective the surface of the asteroid is, it's hard to accurately establish size. Infrared observations allow a more accurate size estimate. They detect infrared light coming from the asteroid itself, which is related to the body's temperature and size. Once the size is known, the object's reflectivity can be recalculated by combining infrared with visible light data. The NEOWISE team measured the reflectivity and size of about 120,000 asteroids in the main belt, including 1,056 members of the Baptistina family. The scientists calculated the original parent Baptistina asteroid actually broke up closer to 180 million years ago, half as long as originally proposed. This doesn't give the remnants from the collision very much time to move into a resonance spot and get flung down to Earth 66 million years ago. This means the culprit asteroid family is still at large, and the culprit of the dinosaurs' demise remains in the cold case files. This video was made possible by Audible. If you are like me and you don't have much time to sit down and read, then Audible may be the perfect solution for you, as it was for me. There are thousands of book titles to choose from and listen to. I'm currently listening to A Brief History of Time by Stephen Hawking, and I'm really enjoying it so far. Audible now also has podcasts. Whether you want to wind down, get motivated, or learn something new, you can listen across all your devices with the Audible app and never lose your place. So why not give it a go? Click the link in the description for a free 30-day trial of Audible Plus. You will not only get a super convenient way to digest lots of books, but you will also be supporting my channel and allowing me to create more videos like this one. Another way to support my channel is through Patreon. The link is in the description. Well guys, I hope you enjoyed this video. I really enjoyed making this. Don't forget to give it a thumbs up and share. You can also subscribe for more videos like this one in the future. I'm working on some new videos about space and can't wait to share them with you guys. All the best and see you next time.